Okay, going ahead with the chapter probability of CBSE 10, we are going to talk about CBSE 10. We are going to understand what probability is. Probability means probable. Okay, when you're not sure what is the outcome of a particular action that you're doing, you may say that, you would say that maybe it is going to be this or maybe it is going to be that. So that is where the conditions of probability come, that you are not pretty sure of what the result is going to be. That's where the probability steps in. So the probability comes from the word probable. Okay, probable, and the easy understanding of probable is maybe. Okay, that is the word that we usually use. Maybe is the word that we use. Okay, now let's consider a few questions. Let's consider how do we calculate the probability. The most basic understanding of probability is done using tossing a coin. Okay, when you toss a coin, okay, so when you toss a coin, what is going to happen? There is only two sides of the coin, and what are the two sides? It is either heads or tails is what you're going to get. Okay, and you will not be pretty sure of whether you're going to get the heads or you're going to get the tails. So you say the probability, you are going to find out the probability in here, and when you're finding the probability, there is a certain formula for finding the probability. It is taken as the probability of the event. Now what is the event? This is considered, the tossing of coin is called as an event. Okay, so the probability of the event is equal to, it is given by a particular formula, and the formula is the favorable outcomes number of favorable outcomes, okay, divided by the total outcomes. Okay, so total outcomes, that means whatever all the possible outcomes are there, all of them should be considered in here. So when I toss a coin, what are the total number of outcomes? Either it can be heads or tails, so it is two outcomes that I have. So the probability of tossing a coin, which is the event over here, is 2. And they said, what is the probability of finding the heads? Probably you have to calculate the probability of heads. Okay, so what do? How many heads do you have? I have 1. This is the favored one that I want, so it is 1 upon 2 will be the probability of it. Okay, likewise, this is one of the major experiments that we majorly used experiments. The other experiment can be, I have a bag. In that particular bag, I have let's say take 3 red balls, and I have 2 pink balls, and I have 2 yellow balls in here. Okay, and they are asking me what is the probability of the question asked is, find the probability of getting, or when you're picking it out, you're going to get when you're picking it out, you're getting a red ball. Okay, so what is the formula in here? The probability of the event, what is the event? Picking of the ball is the event in here, is equal to favorable. Okay, favorable number of favorable outcomes by total outcomes is what you're going to learn. Okay, now this is in short that I'm writing the formula. If you have the time and the energy in the examination, you can go ahead and write the complete formula, number of favorable outcomes divided by the total number of outcomes, or you can just write it as favorable upon total. So what is the event? Getting the red ball is the event when you're picking it out. Okay, so how many favorable outcomes are there? There are favorable outcomes of red is 3. It's not, yeah, pretty sure when I'm picking out, I'm going to pick out only 1 ball. Okay, but it can be any of those red balls that is going to come. So the probability is going to be 3 upon the total outcomes. Total outcomes is, total possible can be 3 plus 2 plus 2. So it is 3 plus 2 plus 2, which turns out to be 3 upon 7 would be the probability of getting the red balls in here. Likewise, what is the probability of getting the yellow ball? So the probability of the event, we are going to use probability of the event itself always. Okay, it is favorable divided by the total, and that can be taken as, how many yellow balls do I have? It is 2 yellow balls divided by the total number of balls, that is 3 plus 2 plus 2, that equals to 7. So this is how you calculate the probability. Okay, so this is pretty much about the probability. Now this is understanding of the probability. Okay, now there are some events which are going to be equally likely events. So the first type of event is equally okay, you have this equally likely events. Now what do you understand by the term equally likely? That means there are equal possibilities of getting the getting the heads or the tails. Okay, let's do it in here. Okay, now we're going to talk about equally likely event. Now equally likely event is wherein, like, the condition of coin tossing. Okay, when I'm tossing a coin, what's going to happen? There is a probability that I'll get a heads or a tail. Okay, now let's find out the probability of getting a head. So probability of the event is equal to, for the heads when I'm finding it out, it is the favorable divided by the total outcomes. What is the favorable? How many are there? It is only one heads. Okay, divided by the total outcomes, it is 1/2. Fine. Likewise, what is the probability of finding the tails? This is the probability for heads. Okay, this is the probability for tails is what I'm finding out. Okay, so the probability is going to be favorable upon the total, and the favorable is, how many head tails do I have? Number of favorable, it is 1 divided by the total number of outcomes. Total number of outcomes is 2. So if you see, the probability of finding the heads and the probability of the finding the tails are equal to each other, which is equal to 1/2, 1/2. So such type of an event where all the outcomes have same probability, those events are called as equally likely events. Okay, they have all events you can say have same probability. Okay, they have the same probability, then that is called as an equally likely event. Let's take another common condition that we have in probability is rolling of a dice. Okay, when I roll a dice, what's going to happen? Okay, now what will be the total outcomes when I roll a dice? 1, 2, 3, 4, 5 and 6 are the total outcomes. These are, any one of this is going to come. Now likewise, if I find the probability of getting an even number when I roll a dice, okay, even number on rolling, when I roll it, I should get an even number. So how many even numbers? Now probability of the event is equal to favorable divided by the total number of things. Now how many favorable do I have? Even numbers, 1, 2 and 3. Okay, so favorable numbers is 3 divided by the total number, 1, 2, 3, 4, 5, 6. So 6, which turns out to be 1/2. Okay, likewise, what is the probability of getting an odd number on rolling the dice? Okay, so what do I do in here? I am going to do it as probability of the event is equal to odd number. How many odd numbers do I have? 1, 2, 3. So again it is 3 divided by 1, 2, 3, 4, 5, 6, 6, which also turns out to be 1/2. So here also we can see that upon rolling a dice, the probability of getting an even number and odd number are equally likely. These are equally likely is what we are going to mention in here. Okay, now you understood. Now if you see, some students may confuse themselves that equally likely means it is always going to be 1/2, 1/2, 1/2, 1/2, 1/2. No, not necessary. We'll see it in the other question 1 minute. Now, so we have understood what is an equally likely event, but we are going to have a little bit of confusion that the equally likely events may have 1/2, 1/2 as the probability. Okay, let's consider another equally likely event that we're going to have. Okay, now let's see that there is a bag. Okay, let's go with this. This is a bag that contains 3 red balls, 3 blue balls, and it contains 3 white balls, and yeah, these are the balls that it contains. And what is the probability of finding the red balls? Okay, so the probability of the event is equal to favorable upon total, so number of favorable outcomes. So red ball, when I'm doing, how many total red balls I have? 3, divided by how many total balls do I have? That I have is 3 plus 3 plus 3, which is equal to 3 plus 3 plus 3, which is equal to 3/9 is what I get. Now when I reduce it, 3 ones are 3 threes are, so it is 1/3 is what I'm getting in here. Likewise, if I'm finding the probability for blue balls, what is it going to be? The probability of the event is equal to favorable upon total. What is the favorable outcome for blue balls? How many blue balls do I have? It is 3 blue balls divided by the total blue balls is 9. 3 ones are and 3s are, so it becomes 1/3. Okay, likewise for white balls, it is going to be the probability of the event is taken as favorable upon total. Favorable is 3, up total is 9, so that becomes again 1/3 is what I get in here. So this is how you get your the equally likely events. So if you see, all the probabilities are same, so these events are equally likely. Okay, okay, now then we have certain events which are not at all going to be possible. Okay, let's consider rolling a dice. Okay, you roll a dice, and what is the probability? Find the probability of getting getting um, a 7, okay, when I roll a dice. So what is the outcomes of the dice? So you're going to write dice, and what are the outcomes? 1, 2, 3, 4, 5 and 6 are the outcomes that I have. Now probability of the event is to get a 7, okay, is equal to favorable upon total. Is there any favorable? Do I get any 7? I do not get any 7. So it is 0 is the favorability there. The total number of outcomes is 6 in here, so it is going to be 0. So this type of an event is called as an, okay, so we have this event in here. So this is an impossible event. What is it? It is going to be an impossible event. It is going to be, okay. Now, so you have understood about equally likely event, you have studied about, then you have studied about impossible event. That's another thing that we have completed. And further we have another event which is called as not equally likely event. So if you consider the event in here condition, okay, one of it you got was like when there was a bag of 3 red, 2 pink and 2 yellow balls, and you found for red and you found then it for yellow. So what happened in here? So the probabilities were different. So this type of an events are called as not equally likely, okay. Not equally likely events is what you get in here, okay. So these are the 3 different types of events that we have. Now there are a certain number of rules for the probability. The first rule being sum of all probabilities this is LITIES, probabilities oh my god, okay, the sum of all probabilities is equal to 1 is what we have, okay. That's the first thing. The second thing is sum of all probabilities is equal to 1. Sum of individual probability, individual probability is either going to be less than or equal to 1, okay. Individual probability is going to be less than or equal to 1. Sum of all the probabilities is never going to exceed 1. Never it exceeds 1, okay. That's one thing we understand. The second thing that we have is the third thing that we have is the probability of an event occurring plus the probability of an event not occurring is taken as 1, okay. The probability of an event occurring plus the probability of an event not occurring is taken as 1, okay. Let's understand this by certain examples in here. So this, for the first one, sum of all probabilities, sum of okay. So when we have these sum of probabilities, what we are going to do is we are going to take the coin thing again. Coin has heads and tails, and when we found the probability of the coin, we got it as 1 by 2 for this one, and for the tails also we got it as 1 by 2. So when I toss a coin, there are only 2 probabilities, and when I consider those 2 probabilities, the sum of these are the only 2 probabilities, right? So these are the probabilities that I'm going to sum. So the probability of getting a heads is 1 by 2 plus the probability of getting a tails. This is heads and this is for the tails. So this is 1 by 2 plus 1 by 2. These are all the probabilities, and when I'm summing them, it becomes 2 by 2, which is equal to 1 again. So this is about the sum of probabilities is what we have in here. Now likewise we have done for the coin. Now we are going to do with the dice thingy, okay. In the dice I'm going to talk about we're going to talk about all the probabilities that we have, okay. The probability of getting a 1, probability of getting a 2, probability of getting a 3, probability of getting a 4, and likewise probability of getting a 5, probability of getting a 6. What is it? How many dice in a dice? What are the things that we have in a dice? We have 1, 2, 3, 4, 5 and 6 is what I have. So probability of getting a 1 is 1 divided by 6. So likewise all of them is 2 is only 1, 2 is given 1 upon 6, 3 is 1 upon 6, so it is 1 upon 6, which is also 1 upon 6, it is also 1 upon 6 and 1 upon 6 in here. So sum of all the probabilities when I'm doing probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 probability of 6 is equal to 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 4, 5 and 6, which is equal to 6 by 6. That again turns out to be 1. Okay, with respect to the dice, again we'll see another example. For the dice, again we had the other equation wherein we are talking about the odd numbers probability and probability of odd number and the probability of the even numbers. Okay, now the probability of odd numbers is how many odd numbers do I have from 1 to 6? Odd numbers are 1, 3 and 5, so it is going to be 3 upon the total outcomes are 6. Okay, which becomes again 1 upon 2, you can take it. Okay, probability of even numbers. Okay, the probability of even numbers, when we are talking about it, even numbers are 2, 4, 6. It's again 3 even numbers divided by the total number of outcomes are 6, so which also turns out to be this. Now sum of all probabilities, when I'm doing sum of all probabilities is equal to 1, we are supposed to prove. So probability of odd plus the probability of even is becoming 1 by 2 plus 1 by 2 again, which is equal to 1. Okay, it becomes 2 upon 2, which is equal to 1. In here is what we understand. Okay, now this is the sum of all probabilities. Now questions will come in the examination wherein they are going to give you the probabilities and they will ask you the other probability. Let's take it. Okay, the question would be like the probability. Let me write down the question. Now this is the type of question that they're going to ask in the examination. The probability that it rains on a particular day, I forgot to write it, on one particular day, the probability of raining is 0.7. On the other day, the sun is going to shine. Find the probability of the sun is going to shine. You know there are only two conditions, either it is going to rain or the sun is going to shine. So probability of rain you will have and the probability of sun you will have. Probability of rain is given as 0.7. Probability of sun shining is not given to you. So, but you know that the sum of all probabilities, we know that VKT, okay, VKT is one of the terms that you're going to use from your 11th standard until whatever you grade you study in, be it chemistry, physics, mathematics. Okay, sum of all probabilities is equal to 1. So probability of raining plus the probability of the sun shining is equal to 1. If this is 0.7, the probability of sun shining is equal to how much? I'm going to send it towards the other side. It becomes the probability of the sun shining is 1 minus 0.7, that is equal to 0.3. Okay, so this is what I get. These probabilities, we are either going to get it in fraction or you are going to write it in decimal. Okay, mostly you're going to write it in decimals itself. So half means 1 by 2, or 1 by 3 becomes 0.33 and all of that and so on and so forth is there. So that's why we say sum of all probabilities is equal to 1. So if the probability of 1 is given and the other is asked, this is how you're going to find the other probabilities. Okay, we do the questions of the textbook and their R.D. Sharma and other books. We will be able to cover more questions based on this. So sum of probabilities is equal to 1 has been explained to you. Now the next thing that we are going to concentrate and study about is the individual probability is never going to be exceeding 1. That is, we have seen it already. That is the second point is need not it need not be explained. What is the second point in here? The second point is that individual probabilities are either less than, okay, sorry, this is greater than I have put in here, sorry, this is less than or equal to 1. They are always less than 1 individual probabilities. Now this is an individual probability. This is an individual odd number. Finding odd numbers is an individual probability. This is an individual probability of finding the even numbers. You see, it is less than 1, it is less than 1. At times, question may come wherein the probability itself turns out to be 1. Okay, probability itself turns out to be 1. So let's take, I'm rolling a dice. Probability of getting a number less than 7. Okay, so less than 7 means rolling a dice. What are the total outcomes? 1, 2, 3, 4, 5 and 6 are the total outcomes that I have. Getting a number less than 7. So less than 7 means How many are there? 1, 2, 3, 4, 5, 6. So the probability of getting a number less than 7 is 6 upon the total outcomes are 6 in here. That turns out to be 1. So it is the maximum probability that you will have is this is the max you can have is 1, or it is always going to be less than 1 for individual questions. Okay, now we have the next one, which is considered as this probability of an event occurring plus the probability of an event not occurring is equal to 1. Not occurring can be taken as this also. So let's move ahead with the formula, that is P, the probability of an event occurring plus the probability of an event not occurring is equal to 1. The probability of the event, we know how to give it. It is given as PE, and the probability of the event not occurring can be denoted by 2 ways. PE dash or PE bar is for not occurring is what you are using, okay. Now after this, let's talk about the rain conditions usually, okay. The probability that it rains on Monday is 0.65. What is the probability? It does. I'm not writing the probability complete word. Probability. What is the probability? The probability that it rains. That probability that it doesn't rain on Monday. Okay, so this is the question that's given to us. So the probability of the rain on Monday is 0.65, and the probability that it doesn't rain on Monday is how much? So I know doesn't rain, that means the complete opposite is given. So the probability of rain plus the probability of no rain is equal to 1. So if the rain is 0.65, then the probability of no rain is equal to how much? So I'm going to send it towards the other side. It becomes the probability of no rain on a Monday is equal to 1 minus 0.65, which is equal to, some who are weak at the subtraction, you're allowed to do it in here. Some of them who are wanting to do, who are good enough at the subtraction, no need of doing it. So it becomes 0.35 is the thing in here we get. Okay, so this is how we are finding out, we are understanding the different formulas that we have for your probability. Further going ahead, let's take the questions from the textbook now. Okay, now before I proceed with anything, there is this very famous card questions that are asked from the chapter probability. Let's understand how are the cards defined as. Okay, there is a very basic structure that I'm going to draw, and then I'll explain how it is done. Going ahead with the description of the cards, we are going to see that there are a total of 52 cards. Okay, this is the cards that you usually play, Teen Patti and Rummy and all of that, right? Okay, Bluff. So those are the cards in here. So there are a total of 52 cards, and out these 52 cards are divided into 26 of black cards and 26 into red colored cards. Okay, now further ahead, these 26 are divided into stacks of 13, 13, 13, 13. The 26 of black are divided into spades, and they are divided into clubs. The red of 26 are divided into 13 hearts and 13 diamonds. Red is for love, and so when we talk about love, it's about hearts and diamonds. All of that is there. So you can remember red falls under the category of hearts, and diamonds fall under the category of the reds. Spades and clubs goes up to the black. Now each section of 13, 13, 13, 13, what do they contain? What are those 13 cards in it? So the first card that is there is ace, denoted by an A. Okay, then you have 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, king, queen and jack are there. These are called as the face cards. So likewise, 13 group is in here. There is another 13 group. There is another 13 group. There is another 13 group. So if the question comes, the jack of hearts, in hearts, this is one set. And how many jacks are there? There is only one. Okay, the jack of hearts. So it is one jack of heart is what you're going to see in here. Okay. So this is the description. So this set is repeating in here, in here, in here, in here. So in one set, there are 3 face cards. In one set of 13, how many face cards are there? There are 3 face cards is what we see in here. Okay, likewise, there are 3 face cards in here, 3 in here, 3 in here. So total of face cards, total number of face cards in the set of 52 are 12 face cards is what we have. In 52, we have 12 face cards. We have 1 ace, 2 ace, 3 ace, 4 ace. So we have 4 aces in the total set of 52. Okay. These other cards are called as numbered cards. Okay, these are called as numbered cards, but these are called as your face cards and these are called as your aces. Okay, so 4 aces, 12 face cards are there in all of this. Okay, in the set of this. Now how many aces are there in red? 1 ace is here, 1 ace is here, so there are 2 aces in here. How many face cards in here? 3 face cards here, 3 face cards here. Total of 6 face cards are here. Likewise for 26 also 2 aces and 6 face cards are here. Okay, now let's start with the question that is given as an example in the textbook of CBSE and CRT. One card is drawn from a deck of 52 well shuffled cards. I did not write all of that. So there are total of 52 cards, and from that well shuffled, the name is given. So that well shuffled means there is no biased picking up. So you know the card which is first is going to be picked up, nothing like that. It has been well shuffled, and whenever you pick up, some different card is going to come. Calculate the probability that the card drawn at random is an ace. So the probability from the 52 deck of cards is the probability of finding an ace is favorable upon total. Okay, so how many aces are there in the deck of 52 cards? We know, we just did that there are 4 aces in here. So it is going to be 4 and the total number of cards is 52. So that becomes 4 ones are, 4 ones are and 3s are. So 1 upon 13 is the probability of it, of finding an ace. That's the first thing. The second, after the first ace thing, the second thing is not an ace they are saying. Not an ace means it's like the probability of finding an ace plus the probability of not finding an ace is equal to 1. We can use this formula for the second one. Okay. So the probability over here is 1 by 13 plus the probability of not finding an ace is equal to 1. This goes in here. The probability of not finding an ace is 1 minus 1 by 13. So that becomes 13 minus 1 upon 13, which is 12 upon 13 will be the answer. That's how I am finding it out using the formula that we have just learned. The probability of an event plus the probability of an event not occurring is equal to 1. Okay. Now, apart from that, if I have to go this with the other method, so how many cards are there? Not an ace, probability of not an ace. If I'm not doing this, what is the other method? I know from the total 52, 4 of them are aces. Okay. So what I'm going to do, not an ace means rest everything leaving the, from the 52, I have to remove the aces, but the total number of cards will still remain 52 itself. Okay, so that becomes 48 upon 52. Then I go with times 12 table. We'll go with 4 table. 4 ones are and 2s are, 4 ones are and 3s are. So it is 12 upon 13. So either you use this formula or you use the normal method. Because he's not talking about an ace, you have to subtract the aces from the total deck. And whatever it comes, that is the non-ace cards. Okay. Divided by the total number of cards. And that is also equal to 12 by 13 and 12 by 13. Okay. Another question that is given in the textbook is, this is also an example question. 2 players, Sangeeta and Reshma, play tennis. Okay, there are 2 girls who are playing the tennis. The probability of Sangeeta winning is 0.62. What is the probability of Reshma winning it? So the probability of Sangeeta winning is equal to 0.62. I know. Then they are asking, what is the probability that Reshma wins it? So when Reshma wins, because they're playing tennis, one-on-one they're playing. Okay. So what's happening in here? If Sangeeta is winning it, okay, then Reshma has to lose. Sangeeta wins means Reshma has to lose. But if Reshma is winning it, then Sangeeta is supposed to lose, isn't it? So in a way, when Reshma's win, they are asking me, they are asking about Sangeeta's losing as well. So the probability of Sangeeta winning plus the probability of Reshma winning is equal to 1. Okay. Sangeeta winning, Reshma winning is Sangeeta losing, isn't it? That's there. Or we can take it as the probability of the sum of all probabilities is equal to 1, because there are only 2 girls, Sangeeta and Reshma. Both the formulas can apply in here. Okay, we have both the probabilities in here. And what are the probabilities that we have? Okay, so it is 0.62. I can use the probability of the event occurring plus the probability of the event not occurring is equal to 1, or I can use the sum of all probabilities is equal to 1. Sum of all probabilities is equal to 1. Okay, this is both, I can use it. Okay, so plus probability of Reshma winning is equal to 1. I'll send it towards the other side. Probability of Reshma winning is equal to 1 minus 0.62. That turns out to be 1 minus 0.62 is going to be 0.3738. Yeah, 0.38 is what I will get in here. Now moving ahead to the next question, it is given that Savita and Hamida, this is a question from the exercise, from the examples given in the textbook. That's why I haven't written the complete question. Now it says that Savita and Hamida are two friends, and what is the probability that they both celebrate the birthday on different days? Okay, different birthdays is what they're going to have. So suppose Savita is having a birthday on one particular day of the year. Okay, one particular day of the year, because it is talking about different birthdays, it is so going to happen that one day Savita will celebrate. So any one particular day Savita will celebrate. Then how many days will be left for Hamida? For Hamida, out of the 365 days, there are total of 365 days. One of the Savita's days should be subtracted, so the total days left for Hamida are 364 days. Okay, so the probability that Hamida for different birthdays is going to be, how many are left for her? She is going to have, Hamida will have 364 days to celebrate her birthday out of the 365. Okay, so this is for the first condition, that is they are both going to have the different birthdays. Okay, the second condition that is given is they celebrate the birthday on the same day. On the same day means only one day both Savita's and Hamida's birthday is going to come. So the favorable outcome will be 1, because there is only one day when both of them are going to celebrate the birthday. So the probability of the event for same birthdays is going to be 1 upon 365 will be the probability over here, is what we understand. Okay, the next question is about the 7th example question, which talks about there are 40 students in a class, and this is about the 10th class exams that they're talking about. There are 40 students of class 10 in this, and out of which 25 of them are given as girls and 15 of them are boys, is what the information is given. I want you to pause the video, go back to the textbooks, read the question, and then come back and start looking at the video in here, or else keep your textbook in front of you so that you understand or read the question as I'm doing it. Okay, the class teacher is going to select one student as a class representative. She is, now how is she going to select one? Only one student is going to be picked up. Okay, now the conditions that are given is that she has written on the separate cards, the cards are identical, and then she puts it in a bag and she's going to pick it out from that particular bag and she's going to read it. What is the probability that it is going to be a girl? So the first thing that they are talking about is a girl. So the probability of the event is going to be favorable upon total. So how many total students are there? It is already given 40 students. I don't have to sit and add these again. It is given 40 students in here. Now how many girls? It is talking about the probability of a girl. So how many girls are there? There are 25 girls. So it is going to be 25 upon 40. Any one will become out of this. So let's go simplify it. 5 5s are 5 8s are. So it is 5 upon 8 is the probability. Likewise, what is the probability that it is a boy? For the boy, there are two ways to do it. Okay, for the boy, the probability of the event is equal to favorable upon total you can do, which is favorable as 15 upon the total is what you can do, which becomes 3 upon 8 is becomes. That's one method. Another method is the probability of the girls winning plus the probability of the girls not winning is not becoming the class, is your class representative is equal to 1, isn't it? That means not winning means the probability of the girl becoming the this is the negation, the probability of the event occurring plus not occurring is equal to 1. We are doing the same exactly goes for sum of all the probabilities. Not the girl not winning becomes the boy is winning it, isn't it, is equal to 1. So this can be rewritten as this. This is already, I got it as 5 by 8. So plus the probability of the boy winning is equal to how much? So I'll send it towards the other side. It becomes 1 minus 5 by 8 is equal to the probability of the boy winning it or the girl not winning it. So that becomes 8 minus 5 upon 8, which is equal to 3 by 8 is the probability of the boy becoming the class representative or the girl not becoming the class representative. It is 3 by 8 here, it is 3 by 8 here again. Okay. Now, another question, the example 8 that is given over here is, it talks about a bag that contains 3 blue. Okay, there are certain marbles kept in. So there are 3 blue marbles, then there are 2 white marbles that are there, and then there is 4 red marbles are there in the box. Okay, now they say that if the marble is drawn at random from the box, what is the probability? It is asking about the white ones first, then it is asking about the second is blue, it is asking about, and then the next one that it is asking about is the red ones. Okay, so what is the probability? Now when we are taking this from a bag, one time one is only going to come to us, isn't it? We are not going to get any more of it. So how do I calculate this? The probability of the white marbles is equal to favorable, that is 2 are there, 2 upon the total, that is 3 plus 2 plus 4, that is equal to 2 upon 6 plus 9 is the probability. Okay, likewise the probability of blue is equal to, blue will be equal to 3 upon 9, which becomes 1 upon 3 if I want to reduce and write it down. Okay, and the probability of red is equal to, how many reds do I have? 4. 4 upon 9 is what I have for this one. Okay, now this is individually, when I'm finding it I can use this, but if I want to use the probability formula that sum of all the probabilities is equal to 1, we found out for white, we found out for blue, we have to find for red. So I'm going to take sum of all probabilities is equal to 1. So this was 2 by 9 plus this is 3 by 9 plus probability of the red I do not know is equal to 1. If the question comes like this, I'm showing you how to do it. This becomes 5 upon 9 plus the probability of red balls is equal to 1. Sending it towards the other side, the probability of red is equal to 1 minus 5 upon 9. This becomes 9 minus 5 upon 9, which is equal to 4 upon 9 is what I have in here for this one. So here also this way you get 4 upon 9, this way using sum of all the probabilities is equal to 1 also, you're going to get the same thing in here. Okay, moving ahead with the 9th question, it says that Harpreet tosses 2 different coins simultaneously. From here on, we are going to talk about the 2 pairs being tossed, or two pairs, that means like 2 coins you're going to talk about, or you're going to talk about 2 dice being rolled. Okay, so when we talk about the 2 dice being rolled, 2 coins being tossed first of all. So one coin is going to have heads and tails, the other coin is going to have heads and tails. So what is it going to happen is, there are 2 outcomes for this and there are 2 outcomes for this. They are going to multiply. The total, for the total number of outcomes, they are going to multiply. So that becomes 4. It is not 2 plus 2, 4. No, it is 2 times 2. That is 4. Okay. For one dice, there are going to be 6 outcomes. For the other dice, there are going to be 6 outcomes. So it is not 6 plus 6. It is 6 times of 6. So there will be total of 36 outcomes that I will have. Now, what are the 4 outcomes that I will have for the coin? Let's see. Heads with heads, head, head. Then head with tail, it's going to be head, tail. Then tail with head, it's going to be tail and head. Then it's going to be tail with tail. Okay, these are the 4 possible outcomes that I will get for this one. Then for the dice, what will be the outcomes? When I roll 2 dices, the first one will be 1 and 1. Both the dices may show 1, 1. 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. They are going to show. The dices will show 1, 1, 1, 2, 1, 3 like that. You can also show 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Likewise 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So these are the total outcomes that you will have when you roll 2 dices. Let's count how many are there. Are they 36 or not? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6 are 36 you're getting. So this is not by addition, this 4, but it is by multiplication is what you're supposed to remember. Now, the question, 9th question starts as, Harpreet tosses 2 different coins simultaneously. 2 coins are tossed simultaneously. Okay, what is the probability that she gets at least one head? Okay, so let's talk about the terms at least, then we'll talk about the terms at most, and so on. Okay, now at least, when I talk about the word at least, what does it actually mean? The word at least stands for minimum of one. Okay, because it said at least one head. At least one head is what they're talking about. So minimum should be one, and it can be any beyond that. Okay, the minimum should be one is what they are saying in here. Okay, so fine. Two coins are tossed. What are the outcomes? I would suggest you to write down the outcomes. So you'll write outcomes. Till the time you're doing it in class, I want you to write it down. Heads, 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 tails, tails, heads, and tail, tails. Minimum one head. One head is here, one head is here, and this is one. It can go beyond one also. So this is the option. So the probability of the event is equal to 1, 2, 3 options upon the total options, which is 4. 1, 2, 3, 4 are the total options. Out of that, 3 are showing at least one characteristic over here. Now, I have told you about the term at most. What does this mean? At most means the maximum. At most one means this is the maximum. Maximum one should be there in it. Nothing can be there beyond one. This is no can be accepted if you consider heads, heads, head, tails, tails, head, and tail, tails is there. It says at most one head. Suppose at most one head is the question that they're talking about. Then how do I do it? Okay, so for this, what I am going to do is, that is the maximum I can have. Minimum can be anything. 1, 2. There is minimum of 0 also. So here also the condition is going to be, for the probability of the event is equal to 3 upon 4. It cannot take this condition in here. At most is, maximum is 1. Anything below that also you can take it. At least means the minimum is 1. Beyond that also you can go. But you cannot take 0 options in here. Is what we understand the difference between at least and at most. Okay, moving ahead to the next 12th example that is given over there is, a carton consists of 100 shirts, of which 88. There are 100 shirts. Okay, now of which 88 are good. Okay, 88 are considered as good, and 8 have minor defects. Minor defects are there, and then 4 of them are having the major defects. Okay, now they are saying that one shirt is drawn at random from the carton. From this carton, one shirt is picked out, and what is, okay, okay, one shirt is picked out at random, but there are 2 people. There is this person named as Jimmy, and there is this lady named as Sujata. Okay, now the condition for Jimmy is that he accepts only good shirts. Good shirts, he is going to pick it up. Sujata, if you're talking about, Sujata is not going to take the shirts with the major defects. So she's going to take 8. She's going to take the good shirts plus the minor defects also she's going to take. Okay, so 88 she will take plus 8 she will take. But Jimmy, if you are talking about, he'll take the 88. From those 88 shirts only he'll take. Now the probability is one shirt is drawn out at random. What is the probability? It is acceptable to Jimmy. Jimmy does what? He takes only good ones. So total shirts are how many? 100 total shirts are there, and out of which 88 are good. So the probability goes as 88 upon 100 for Jimmy, which turns out to be 0.88. Okay. Then further ahead, it talks about acceptable to Sujata. Acceptable to Sujata. Okay. So when we talk about acceptable to Sujata, for her also there are total of 100 shirts. Okay. Out of this, she's going to take the good and the minor defects one. She's not going to take the major defect. So 88 plus 8, which is equal to 96 upon 100, which turns out to be 0.96. It will be the probability that we will get for her. Okay, moving ahead with the 13th question, it says that there are two dice that are being rolled. Okay, so one of the dice is blue in color and the other one is gray in color. Okay, now when you roll two dice, there's something that's going to happen. Now what is that something that is going to happen actually? Okay, that something that is going to happen is you get, suppose this is one die that I'm rolling, this is the other die that I'm rolling. So what actually is going to happen is the numbers that show up, I'm adding them to get the sum of it. Okay, so if you see, they are giving what is the probability of getting the sum as 8, what is the probability of getting the sum as 13, what is the probability that you can get less than or equal to 12. Okay, fine, understandable. Okay, so now I'm going to consider this table, sum of 8. So one dice is showing 1, the other dice is also showing 1. When I add them, it is 2 only. This will be 3, this will be 4, this will be 5, this will be 6, this will be 7. Maximum is 7. Here I'm not going to get 8. 8 is 2 plus 6 will be 8. Okay, now most of the time they are in a diagonal additional order. Okay, so what you see, 2 6 will be 8, 3 5 will be 8, 4 4 will be 8, 5 3 will be 8, and 6 2 will be 8. No other numbers will sum up to 8. Okay, no other numbers will sum up to 8. 4 3 7, this will become 9. 3 4 7, this will become 9. So it will be like that. Okay, so 1 2 3 4 5 are the options. So the probability of getting the sum as 8, the probability of getting the sum as 8 is going to be, it's going to be 36 is the total outcomes that you have, and out of that the 8 ones are 1 2 3 4 5. So I'm going to write it as 5. Now you can just write it as 5 because you will anyways make this table in a rough column and you're going to mark them. So if you want to write sum as 8, sum of 8 is equal to, you can write the pairs as well, 2 6, and you have 3 5, another pair is 4 4, another pair is 5 3, another pair is 6 2. Okay, and this would be your probability. Then it says sum of 13. Sum of 13 I have to search for. Where do I search the sum of 13? The maximum that I get is 6 plus 6 is 12. I will never get it 13 in this. No matter what I add, maximum I am going to get is 12. So the sum of 13 is not possible. 0 terms are there. So probability of the sum of 13 is an 0, impossible event. Okay, it is an impossible event in here. Okay, then after that we have the next one. It says less than or equal to 12. Fine, anything equal to 12 or less than that. So 0 also is possible, but we don't get zeros. We start from 2 itself. When you're adding them, one dice is showing 1, the other dice is also showing 1. So we are starting from 2 itself. 2 to 12. 12 is what? Here I'm going to get. So all of them we are considering in here. Okay, all of them we are considering in here. All of these options. So sum of less than or equal to 12. So the probability of less than or equal to 12 is equal to all 36 options upon 36 is what I get, which is equal to 1. And such events where the probability is 1 are called as surely likely events. Surely likely events is what will be named as. Okay, all the ones will be less than 12 and 6 will be equal to 11, equal to 12. So all the options will come in here. 36 upon 36, that sums up to 1, that cancels to 1, and so this is the 1 is the probability, and it is called a surely likely event. And this is the end of the examples. Starting ahead, we will have your exercise questions in the next video.